As I have discussed in previous chapters, C++ provides numeric data types, such as short integer, long integer, and float, for storing numbers, and a character data type for storing one character only. However, unlike many other languages, C does not provide a built-in string data type for storing more than one character of data. In other words, for storing data such as a person's name or an address. Although the string data type is not built into the C language, you can indeed implement it using the C's character data type. You will note that the syntax for declaring a string variable is almost identical to the syntax for declaring a character variable. Recall that you create and initialize a character variable by using the char statement. Similarly, you create and initialize a string variable by using the char statement also. The difference is you use square brackets to indicate the size of the variable. The number inside of the square brackets is a number that is one more than the maximum number of characters you want to store in the variable. For example, to store 11 characters in a string variable, the value in the brackets must be 12, which will store the 11 characters plus the null character that C automatically adds to the end of a string. The number in brackets actually tells C how many 1-byte memory locations to save for each use of the string variable, plus the null character. Unlike character variables, however, which you typically initialize to one space enclosed in single quotes, string variables are usually initialized to a zero-length string. A zero-length string is simply a set of double quotes with no space in between, such as you're seeing now. I'll compile this program to see the effect. As you can see, it compiles without a problem, and we now execute. If I type in a person's name, such as John, and press the Enter key, you'll see that the program responds as you might expect. What the program is simply doing is accepting data from the keyboard after a prompt and then displaying the result with a cout statement. The data can accept more than one character since we have declared that number inside the brackets. In essence, we've created a string variable by using the character data type. Now let's run the program one more time. And this time I will type in the person's name along with their last name, leaving a space in between the first and last name. As you can see, the value of the variable is simply John, not John space Smith. The reason for this is that a string data type, which is actually a multiple of character data types, will not accept a blank space. As soon as this space was entered, the data was terminated and no more characters were accepted by the keyboard. You will recall that the CN extraction operator stops reading characters from the keyboard as soon as either the user presses the Enter key or types a character that is inappropriate for the variable's data type. In the case of string variables, an inappropriate character is the space. Another important note, if a user enters more characters than the string variable can store, C stores the additional characters in memory locations adjacent to, but not reserved for, this variable. Storing additional characters in these unreserved locations may write over some important information in memory, perhaps even crashing your system. Since it is common for string constants to contain one or more spaces, the next section will show you a different way to enter data into a string variable, a way which will allow the data to contain spaces. You can use one of the CNStream's member functions called getLine to enter data that contains spaces into a string variable. This will be discussed in the next segment.